A conical container is made by rotating the shaded area shown in the graph around the y-axis. The area is bounded by the line shown here. We can see this clearly on the graph. Use calculus methods to determine the volume of the material used to construct the container. We're rotating around the y-axis, so v is going to be pi times the integral of x squared dy. Now let's look at the outside first. We didn't do a very good job of drawing that, so let's use the straight line down there. So the outside, clearly this boundary is the 2x, and it goes all the way down here to the axis. So we're going to have pi times the integral from 0 to 11 of, so y equals 2x for this line here. So x is y over 2, so that will be y over 2 squared dy. And then we'll have to take away the inside cone. So we can see that goes from 1 up to 11, and the boundary here is y is 2x plus 1. So x is going to be y take away 1 over 2. So what we're going to have there is pi times the integral from 1 to 11 of y minus 1 over 2, or squared dy. So we can just calculate this on the calculator. So let's bring the calculator in. And interactive calculation integral. We're going to want a definite integral. And for the first expression, we have to use x instead of y in here. So that's going to be x divided by 2, all squared. And our limits are going to go from 0 up to 11. So that's going to be 1331 over 12 pi. And then for this next one, we'll do the integral. It's got to be a definite integral again. This time it's going from 1 to 11. And the expression is going to be x take away 1 squared divided by 2 squared, which of course is 4. So that gives me 250 over 3 pi. So we do this one, take away this one, we get 331 over 12 pi, and as a decimal, so let's convert that to a decimal, times that by pi, and as a decimal, that is 86.7 cubic units.